Introduction to Organic Compounds. In this chapter, we will talk about the classification of different organic compounds, nomenclature, structure, and physical properties. Hydrocarbons. What are hydrocarbons? Hydrocarbons are organic compounds which contain only carbon and hydrogen, and they are classified under two different heads: saturated hydrocarbons and unsaturated hydrocarbons. In saturated hydrocarbons, there is only single bonds present. There is no carbon-carbon multiple bonds. Whereas in unsaturated hydrocarbons, you may have one or more carbon-carbon multiple bonds, such as double bond or triple bonds. Alkanes fall under the category of saturated hydrocarbons, where it has only carbon-carbon single bonds or carbon-hydrogen single bonds. Whereas under the unsaturated hydrocarbons, we have three different types. One is alkenes, which has carbon-carbon double bond, and the other one is alkynes, which has carbon-carbon triple bond, and aromatics is something which is going to have a benzene ring. First, we'll see how alkanes are named, because the names form the basis for the names of all other organic compounds. What are alkanes? So alkanes are compounds which are composed of only carbon atoms and hydrogen atoms, and they only have sigma bonds or single bonds. Carbons and hydrogens and single bonds. Alkanes can be either straight chain alkanes, where the carbons are arranged in a row, or they can be branched, where some of the carbons are going to exist as branches on the long carbon-carbon chain, or they can also be cyclic. Here is the nomenclature and the physical properties of some straight chain alkanes, where you can see that methane is the simplest alkane that you can have, which has got only one carbon. And the condensed structure of methane is CH4. And if you want to write down the line bond structure of methane, it's going to look something like this, where the four hydrogens are arranged tetrahedrally around that carbon atom. And the next one in the chart here is ethane molecule, which has got two carbons, and the condensed structure of ethane is CH3, where the two carbons are linked together by a sigma bond, and each of these carbons is going to have three hydrogens. And similarly, propane molecule has three carbons which are arranged in a row. Each of the terminal carbons is going to have three hydrogens, and the one in the middle is going to have two hydrogens. So on the whole, each of this carbon is going to have a total of 4 bonds. If there is an alkene that has got only one carbon, it has to start with meth. If there are two carbons, it should start with eth, and all of these need to end with ane, right? So you can see like all of these are alkenes and these are ending with ane. And depending upon the number of carbons, you're going to use prefixes such as meth, eth, prop, but, and so on. Now the family of alkanes here in the table is called as homologous series. In Greek, the term homo means the same, right? So in a homologous series, each member differ from the one that is before in the series by one methylene group. Let's consider ethane. What is the difference between ethane and propane? You can see that there is one CH2 extra. And then between propane and butane, you can see that there is one more CH2 that is present in excess. So these are called as the members of the homologous series. So the homologues differ by a CH2 group. Structure of alkanes. The shape of the alkane around the carbon is tetrahedral, where all the bond angles are approximately about 109.5 degrees. We can choose to draw the alkane structure in one of these forms, where this is the Kekulé structure, or it's called as the line bond structure, and this one right here is the condensed structure, and this is the ball and stick model. And the general formula for alkanes is going to be CnH2n plus 2. If we choose to put n equals 1, then the number of carbons is going to be 1, and the number of hydrogens is going to be 4. So on the whole, it's going to represent the methane molecule. And if you choose to put n equals 2, the number of carbons is going to be now 2, and the number of hydrogens, now it's going to be 6, and it is going to represent the ethane molecule. When you have the molecular formula C4H10, it can be arranged in two different ways. You can try to put all the four carbons in a straight chain, in which case it is going to be called as N-butane, where the N here is going to stand for normal, meaning that all of these carbons are arranged in a row. The second way to draw the structure is to put one of the methyl groups as a substituent on the propane structure. This one is called as 2-methylpropane. Now these two compounds are definitely different, and we are going to call them as constitutional isomers. Now what are constitutional isomers? These are compounds which have exactly the same molecular formula, but they're going to have different structural formula. The atoms are linked differently. Similarly, if you take the case of C5H12, it can be arranged in three different ways. You can choose to put all the carbons in a straight chain, such as this, and in which case this is called as N-pentane. Or you can put one of the methyl groups as a branch substituent on a butane structure, or you can put two methyl groups as substituents coming off from a propane. Okay, and all of these are constitutional isomers of the molecular formula C5H12. Similarly, C6H14 can be arranged in 5 different ways. And C7H16 can be arranged in 9 different ways. Alkyl substituents. When you remove a hydrogen from an alkane, then it is going to result in an alkyl substituent. Say, for example, to begin with, let's say that you have CH4. When you replace one of the hydrogens with something else, then it's going to become an alkyl group. So after you remove one hydrogen from there, it's going to become a CH3 group, and that CH3 group is called as a methyl group. Similarly, let's draw the structure for ethane. So here is ethane. When you remove one hydrogen from here, then it's going to be an ethyl group, but make sure to put the bond right there because it is connected to something else. And this is propyl group and this is butyl group. So in general, an alkyl group can be represented by the letter R. So this is going to represent the letter R is going to represent any alkyl group. Here are the common names for the molecules. When you have an OH group attached to an R group, which is basically an alkyl group, then it's called as an alcohol. When you have an NH2 group attached to the R group, then it's called as an amine. When you have an X is going to stand for halogen, and this halogen could be either fluorine, chlorine, bromine, or iodine, then it's called as an alkyl halide. And when you have an oxygen between two R's, it's called as an ether. Let's see if we can find the names for these molecules. Common names for these molecules. The common names is going to be alkyl followed by the name of the functional group. So here the functional group is an alcohol. So basically it's going to be represented as alkyl alcohol. And this one should be alkyl amine. And this one should be alkyl halide. Okay, let's write down the name for these molecules. So this one, it should be methyl alcohol, since you have only one carbon in this alcohol. Here there are two carbons, and therefore this should be ethyl followed by amine. And on this one there are totally 3 carbons, and you have an halogen there, so it should be an alkyl halide. And to be more specific, this is propyl bromide. And this one right here is butyl chloride. Similarly, this is methyl iodide. This is ethyl alcohol. This is propyl amine. And this is ethyl methyl ether. So all of these examples that we have seen, all of these names right here are common names. What is the difference between a propyl group and an isopropyl group? Okay, when you have a propane group, okay, you can choose to remove the hydrogen from the terminal carbon, or you can choose to remove the hydrogen from the internal carbon. So if you choose to remove the hydrogen from the terminal carbon, then it's called as a propyl group. If you choose to remove this hydrogen, then it's called as an isopropyl group. And once you remove the hydrogen, then you can replace it with any group. Say, for example, you can replace it with an OH. In that case, it's going to be an isopropyl alcohol. Or you can replace it with an halogen. In that case, it's going to be an isopropyl chloride. Molecular structures can be drawn in different ways. For example, isopropyl chloride is drawn in two different ways. For instance, if you look into the two-dimensional representation, it might look as if like they are different compounds, but the structures are identical because the carbon is tetrahedral. The four groups which is bonded to the central carbon, namely the hydrogen, the two methyl groups, and as well as the chlorine, they all point to the corners of a tetrahedron. So if you take this structure on the right and rotate this clockwise to 90 degrees, then you will get this structure. So basically, both of these structures, both of these models are one and the same. The differences between primary, secondary, and tertiary carbons. A primary carbon is a carbon which is connected to one carbon, and a secondary carbon is connected to two carbons, and tertiary carbon is connected to three carbons. So this carbon right here is a primary carbon since it is connected to only one carbon. And this carbon is connected to two carbons. So here are the two carbons that it is connected to, and therefore this carbon is a secondary carbon. And this carbon is a tertiary carbon since it is connected to three other carbons. Now let's also look into the difference between primary hydrogens, secondary hydrogens, and tertiary hydrogens. The hydrogens that are connected to the primary carbons are called as primary hydrogens. So these hydrogens here are called as primary hydrogens. And since this is a secondary carbon, the hydrogens that's connected to it is called as the secondary hydrogens. And similarly here, this is a tertiary hydrogen. There are four alkyl groups that have four carbons. The butyl group, isobutyl group, the secondary butyl group, and tertiary butyl group. In both the butyl group and isobutyl group, we will be removing the hydrogen from the primary carbon. So this is a primary carbon. A primary carbon is something which is attached to two hydrogens and one carbon. And similarly, if you take a look into this, this is a primary carbon because it is attached to two hydrogens and one carbon. And for the secondary butyl group, we'll be removing the hydrogen from the secondary carbon. A secondary carbon is something which has got only one hydrogen. And for the tertiary butyl group, you will be removing the hydrogen from the tertiary carbon. A tertiary carbon is a carbon which is connected to three carbons or no hydrogens. In the common names, we normally use N. The N is going to stand for unbranched chain. For example, the structure right here is called as butyl bromide, or it can also be called as N-butyl bromide. You can use the term, you can use the symbol N in the front. This N is going to say that all the carbons are arranged in a row. And similarly, this is pentyl fluoride, or you can call this as N-pentyl fluoride, meaning that it is not a branched structure. Using the examples here, we are going to find out how the prefix iso is used appropriately. In all of the examples here, you can see that the iso is at one end of the molecule and the substituent is at the other end of the molecule. Take a look into this first compound. So you have the iso here and the substituent here. Iso here and the substituent is here. The second thing that you have to note down here is the iso group has a methyl group on the next to the last carbon in the chain, right? So in all of this, the iso group has a methyl group on the next to the last carbon of the chain. The third important thing you have to note down here is all isoalkyl compounds have a substituent attached to the primary carbon. This is a primary carbon where the substituent is attached, primary carbon, and this is also primary carbon. But only in the case of isopropyl, the substituent, here in this case bromine, is attached to the secondary carbon. So you can very well call this a secondary propyl bromide, but then the chemists decided to call it as isopropyl because they wanted to reserve the term secondary for secondary butyl group. Here are the names of some alkyl groups which would be useful in the naming of the organic compounds. Methyl, ethyl, propyl, butyl, pentyl, and hexyl, these are all straight chain alkyl group, right? Isopropyl group is a branched chain, and where you can see that this is the isostructural unit. And similarly, this is isobutyl because you have 4 carbons on the whole and you have the isostructural unit in it. This is a secondary butyl group because the substituent, whichever you're going to put in, whether it's a halogen or whether it's an hydroxy group, it is attached to a secondary carbon. And similarly, this is a tertiary butyl group because the substituent here is attached to a tertiary carbon. And this is an isopentyl group because there are totally 5 carbons and you also have an isostructural unit in here. And similarly, this is an isohexyl group because there are totally 6 carbons and you still have the iso group at the end.